Hey guys, it's me again. Yeah, I got a new set of glasses. They look uneven. I had to get them adjusted. Anyway, as I hinted at on previous video, that I've got a new project coming up, and don't take a chance on this. But let me show you what I got. It is a Hewlett-Packard 200 CD wide range oscillator. Let's see, property of Kierfot, serial number 46, contract number 4865, asset number 56, but Kierfot Aeronautical, if I can read that right. Never heard of them, but anyway, it's a variable frequency signal generator, or audio signal generator. One big old knob. Seems to be a little stuck. You have a ground here, 600 ohm output right here, common ground if you want to put a shield on it. This is your output amplitude right here. Go from 0 to 100%. This here is your range switch. So like if R times, you know how this stuff works, but you know, like right now if it's R times 1, that's 25 hertz, 250, 2500, so on and so forth, 250,000, and anyway, I just brought it in here, and Teledyne Metrology, but this sticker doesn't look, it may have been, it doesn't look like it's been harmed, and somebody's been in it, but the sticker says test bad, tested 6/9 to 22, so whatever that means. So just a quick evaluation, I guess. I want to put you all guys in the tripod. And what I'm going to do, we're going to take the cover off this bad boy. And that is a flathead. Imagine that. It is hot out there today. My outside thermometer says 98 degrees. It is plain hot down here in northeast Louisiana. I'm going to see how good the transformer is on this thing. That's my biggest fear. If the transformer's shot, then this is nothing more than a boat anchor. In other words, this is $90 of waste right here. Turn it on its face. Pull the covers off. Have a look at it. A little nasty. Not really nasty, I've seen worse. But all the tubes appear to be there. 6HS7, a couple of pilot tubes. There's another 6HS7 pilot lamp right there. There's your tuning gang right there. All seems to be non-molested. There's a rectifier tube. There's 1, 2, 3 filter caps, and then 2 more tubes. So this is a Hewlett-Packard tube, so that's one. That's another Hewlett-Packard, so that's 2. Okay, here's a 6AU5, that's a Tungsol. So then a Sylvania 6AU5, so those two are not original. And a Mullard 5Y3. This is the rectifier here. So we got 1, 2, 3, 4, 5 tubes in this thing. 2 out of the 5 are original. Let's see, I'm looking for anything on that's been molested. Everything looks intact. A little bit of smudge right there. That's interesting. It comes from that resistor. It looks like it's been getting hot, which, oh yeah, these dudes, look at that. Oh Lord, that resistor's gotten super hot. See, it's turned white. It's supposed to be green like this one. So we got issues. 90% chance that the filter caps are bad. Filter, there's like a filter choke right here. Another transformer here. And there's another transformer on top. So what I'm going to do is I'm going to take the rectifier out. I'm just going to put my variable isolated power supply on here and with my dim bulb, and I'm going to look to see if the filaments come on, and then I'm going to look at the secondary or the primary voltage of this or the secondary, high voltage secondary of the power transformer, and see if I'm getting all my voltages. But I think first thing I'm going to do is just get a schematic so I can get a little more clear explanation of what's going on. So I will bring you back. Okay, what I've got is I've got my variable isolation transformer connected to my dim bulb tester, which is up in here. I got it on the low output, which I think is a 110 watt bulb, connected straight to the rig. I've got the rectifier tube. This what is this stupid thing? That's a 35 something another. Actually a 5AR4. Well, it says they're 5Y3. Okay, I knew something was wrong. Anyway, I'm going to turn it on. Let's see what happens. Now, mind you that I have I'm going straight into the device. I'm not drawing any current, which is not a good thing. I'm not drawing no current. That's not good. Let me double check my settings. Okay, round 2. Had it connected wrong, so I'm going to bring it up. I'm going to bring it on up to full voltage. I do have a little bit of light going on, but it is dimming. That means the filaments in the tubes are warming up, and when they warm up, you know, when they're cold, the resistance of the filaments is really low, and as they warm up, the resistance increases. So that's why when you turn this stuff on, where is that bulb at? There it is, way right there. looks pretty. Anyway, I do have filaments. So, you can see that or not. So I do have filaments. That's good. So now I'm going to turn it off. And I'm going to not bore you with the details, but I'm going to connect to the plate of the rectifier tube and see if I've got secondary high voltage. So I'll be right back. Alright. I hadn't figured out the picture-in-picture stuff yet, so I'm just going to do it old school. Anyway, this is the primary lead right here, and this is the power transformer right here. It's set up. These straps right here is how you set it up for 115 or 230. In our case, it's 115. So I just connected my clip leads to my cheater cord here, and here for my AC, bypassed all this other mess. Anyway, this is the filament for the rectifier right here. You can see it 5 volts. That's what drives the filaments of the rectifier. And basically what I went and done, and here's the filaments of the tubes in the rig. And as you saw just a minute ago, they were all working. So I know that because the filament's working, I know this is working. I'm not real worried. I've never had a problem other than a shorted ground rectifier filament issue was right here. But I have this 5AR4, which is a 5V4 tube. I have that pulled out. So here's the high voltage secondary. It's referenced. This is the reference here, but basically I've attached my AC voltmeter from here. This is the plates, by the way. Pin 4 and pin 5, I think. No, I'm sorry, 4 and 6. I can't tell, I don't remember. But anyway, I'm connected here to here with my voltmeter. I'm going to turn this thing, I'm going to turn my variable isolated power supply from 0 up. And we'll bring it up slowly back to 120. And we'll see if I'm getting filament voltage here. And I'm just directly across this right here. Not filament voltage, I'm sorry, high voltage secondary voltage right here. And if I have voltage there, then this transformer is good. And that's really all I kind of wanted to do with this video, is verify that this transformer is good and not damaged. Because if it's good, everything else in this is completely repairable. But if this transformer is bad, then it's game over. The other problem, there was another transformer that I showed you underneath. That is this transformer right here. This is actually the output transformer. It's a very high frequency or low frequency transformer, and it's a very good audio transformer. And I'm just looking at it. Quite interesting setup. We'll have to look at that later on, exactly what they're trying to do here. But it looks like as you change frequency ranges, maybe, yes, that's what it is. It changes, adds more. It adds more or takes away from the primaries. So we'll look at that the next time. But let's go check for high voltage right here, between here and here, and see if I can zoom that in a little bit more. Yeah. There we go. Anyway, it's I can't, that's 8, 2, 8, so it is 4 and 6. So I've got my voltmeter set up on 4 and 6 here, so let's go power it up and see if we got what we got here high voltage. It says here 315 volts from the center tap to one side, so we should see something in the order of 585 to 610 volts because I have it in that dim bulb. Let's walk over here, and I got the voltmeter set up. So I'm going to move this voltmeter over. Alright, here we go. Not too worried about the current draw. Here we go. We'll bring it up. Okay, I'm at 20 volts right now, coming out of the AC. I'm 107 already. We're at 40 volts. I'm at 188. So far everything's looking good. I'm at 60 volts on the AC primary. I'm getting about 28 volts. Well, I'm sorry, 290 volts. We're at 80 volts primary. 395, so we're halfway there. I'm at 100 volts on the primary, if you can see it. I'm at 490. So I'm just going all the way up to 117 volts. I have 565 volts. 570, that's about right. I'm good with that. Let's go ahead and bypass the dim bulb tester. I'm going straight on. Here we go. We're just going to bring it up. If it's going to blow up, it's going to blow up. Look at there, 690 volts secondary, high voltage secondary. So I would say the power transformer is good. Get my test leads off there. Unplug the cheater cord. This is what I call my cheater cord. It's basically 2 clip leads on the end of an AC line, and I use that when I'm working with my oscillation transformer or whatever. That makes it easy to clip on to such things like this. In this thing's case, the cord has been cut off right here and the fuse holder's missing, but I was attached right here and right here on this terminal strip. There's, if you can see it, the little jumper. Anyway, that corresponds to this and this. So that was a convenient place for me to attach my AC input voltage. So next thing I want to do is I just want to make some ohmage checks, and just to see if there's any appreciable shorts. I'll bring you back when I'm set up. All right, we got a little storm brewing here. Anyway, I've got my my triplet 630 PL set up as DC ohm meter right now. Hold on. All right, I told you a few minutes ago that we had a storm coming through, and if you heard my phone go off, that was some of my system alarms going off. I had one site lost electricity, or momentary power outage, and then then I had another site that lightning got too close to it and reset some stuff. But it seems to be okay. But anyway, what we're doing here is I'm just going to use my ohm meter here to check for shorts. And that's about all I'm going to do is I'm going to check for shorts on this thing. But on this power supply here, out of the main rectifier here, we're going to look at C13A and C13B and then 13C. These two are tied together. So I don't know where those are, so let's just find the 2 yellows going to, there it is right there. There's the 2 yellows. So I'm just going to probe that point. And it was a nice healthy deflection, so that's not bad. That was this capacitor charging, so that would be this capacitor right here. So this is the first capacitor. You'll see it doesn't look the best in the world. That's going to be this one right here. Now that's good. This one here measures the same, no appreciable shorts, nothing major. And then these two are tied together, as you can see right there. So let's see, then 10C, yeah, that's part of this. So this is 10A right here. Where are you? Hang on, I can't see nothing in the viewfinder. This is 10A right here, this is 10B, and this is 10C. These two are tied together. And then this is ground. Okay, so okay with that, I'd like to know where these resistors are, and that comes off of here. For those to get so hot, it comes off here, so let's have a look at that. That's got some continuous resistance on it, as does this one. That's ground. So I think the next step in this right here, everything for these to do that, for these resistors to do that, they're drawing more current than they're designed to pull. And I'm not going to do it at this episode here. This is just kind of evaluating. This episode is all about evaluating this rig. I will probably the next phase is I'll unhook these caps, put them on my checker to look for leakage. But if you look right there, can tell you right now, if you look right there, you'll see that little bulge, that little black junk coming out of that cap. Right there, I know that cap's bad. This one doesn't show it, nothing coming out of it, but I can guarantee it's leaky. And if I look real careful, I can't see much on that one. That one's going to be a booger. I'm going to have to pull this choke out to get to this one. But on the next episode, I'll pull those out, or I'll unhook them, and each one at a time, and I'll check them. I don't think it's going to be a big deal. That's really all that's going to be wrong with that. I'm not going to power it up. Anyway, I'm done. I'll see you on the next episode. Thank you.